Assalamualaikum and good day everyone. So right now we are Group 1 from CEC 1104B. We'd like to present our mini project ECS268 Sustainable Hollow Concrete Brick. And let me introduce our group members. So we have myself and Najman, Alif Haikal, Muhammad Amar, and Muhammad Faris. Without further ado, let me start from the introduction first. Okay, the construction industry is one of the major contributors to carbon dioxide emission due to the extensive use of conventional concrete materials. As a result, there is increasing interest in developing sustainable construction materials by incorporating agricultural waste into concrete products. Coconut fiber, a renewable and biodegradable byproduct of the coconut industry, is gained attention because of its good mechanical properties and environmental benefit. In this project, 5% coconut fiber was incorporated into hollow concrete bricks to evaluate its effect on the brick's physical properties and compressive strength while promoting sustainable construction practice. And in project or in our research, our objective is to produce sustainable hollow concrete bricks by using coconut fiber. Second, to evaluate the physical properties of the fabricated bricks. Third, to determine the compressive strength of the bricks. And finally, to promote sustainable construction practice. And as I said before, our group decided to use coconut fiber because of its advantages. So the advantage of the coconut fiber is first, coconut fiber is a lightweight material, which is help us to produce a light concrete bricks. Second, coconut fiber is a high toughness material. Third, it has a good grip resistance that can help us to produce a high tensile load resistant concrete bricks. And finally, of course, coconut fiber is an eco-friendly material because it comes from the natural resource.
Okay, thank you, Anik, for the introduction. So next, we move to methodology. So our main goal is to test how concrete bricks perform whether we replace 10% of gravel with the processed coconut fiber. To keep the test fair, all the brick will have the exact same size even though we are using the agriculture waste. We want this brick to be strong, targeting as grade 30 or 30 megapascals that strength standard. Next, we move to brick design. So let's look at the design. Before the mixing, we prepare the precise mold that matches standard commercial brick. We are using two hollow design. The brick size is 220 mm long, 100 mm width, and 70 mm thick. It has two hollow cavities inside, and we ensure there are at least three 30 mm concrete layer around the hollow to keep the structure safe. Next, we move to volume calculation. To know how the material we did some simple math. First, the gross volume of the hollow brick is 0.00154 meter cubic. Next, hollow volume for the two cavities is 0.000364 meter cubic. By subtracting the whole from the total size, we get the net concrete volume, which is 0.001176 meter cubic. This tells us the exact amount of concrete we need for our brick. Next, we move to mix design. Based on the volume, here our recipe for the one single brick, 1.475 kg of cement to the bind everything, 0.737 kg of water for the chemical reaction, 2.359 kg of sand as a filler, 4.618 kg of gravel for the main strength, and finally 0.124 kg of coconut fiber as our 10% green replacement. Next, we move to material preparation. Before mixing, material preparation key is for coconut fiber. Before mixing, material preparation is a key. For the coconut fiber, we wash it thoroughly, dry completely, and in an oven under the sun or doesn't affect our water ratio. And they chop it uniformly. For the aggregate, the sand, gravel are safe and kept dry before we weigh them precisely using the digital scale. So we move to the next slide is mixing, making and making the bricks. Now for the production part, dry mix, we mix the cement, sand, gravel in the mixer for 1 minute. Then we add the coconut fiber slowly so it doesn't clump together. Wet mix, we pour out the water in the slowly and mix for another for 2 to 3 minutes until it becomes smooth, even mixture. And for the casting, we pour the concrete into the soil, into the solid mold, into a layer. Each layer is vibrate on a machine to remove any trapped air. For- And finally, curing and testing. We let the bricks set for 24 hours before taking them out of the mold. Then we submerge them in the water for 7 days for the curing process. After 7 days, we we do two tests. Physical test, which to check the final look, size and weight, and mechanical test. We crush the brick vertically and horizontally to test their strength and how see they hit our 30 megapascal target. So we move to the next slide. Okay, thank you.
For our concrete mix design, coconut fiber was utilized as the aggregate replacement material. The chosen replacement percentage was 5%. The casting took place on the 24th of June 2026 and the curing process commenced on the 25th of June 2026. The mix consisted of 1.475 kg of cement, 2.359 kg of sand, and 4.618 kg of gravel. Additionally, it contained 0.737 kg of water and 0.124 kg of coconut fiber. Our goal was to evaluate the feasibility of incorporating agricultural waste into concrete. During preparation, the fibers dispersed evenly throughout the mixture. The mix became slightly less workable because porous fiber absorb some of water. However, with proper compaction, we successfully produced hollow bricks with an excellent finish and no fiber segregation. After a 7-day curing period, the bricks weight decreased from 2.440 kg to 2.270 kg. This 7% reduction occurred mainly due to water evaporation and the lower density of the coconut fiber. This lighter weight offers advantages like easier handling and lower dead load. During testing, the brick withstood an ultimate compressive load of 100 kN. The fibers significantly improved the concrete toughness because they bridge small cracks and delay crack propagation. Ultimately, the 5% replacement proved highly effective in creating a strong, lightweight, and sustainable construction material. The study evaluated the incorporation of 5% coconut fiber into hollow concrete brick. These results show a weight reduction of approximately 7% after a 7-day curing period. This reduction resulted from water evaporation and the naturally lower density of the coconut fibers. Despite its lighter weight, the brick successfully achieved an ultimate compressive load of 100 kilonewton. The incorporated fibers act as micro-reinforcement which bridge small cracks and delay crack propagation. Furthermore, the fabricated brick met the uh, specified dimension flawlessly. This finding suggested that the brick posed adequate adequate strength for lightweight or non-load-bearing construction. However, certain factors like non-uniform fiber distribution and the testing for only a single specimen might have influenced the final result. To improve future consistency, we recommended washing and drying the fibers thoroughly, ensuring proper compaction and testing multiple specimens.
Thank you, Ali. So I'm going to conclusion. The objective of this study was to investigate the suitability of 5% coconut fiber as a sustainable material in hollow concrete brick production. Based on the experimental results, the coconut fiber was successfully incorporated into the concrete mix and producing a lightweight brick with an ultimate compressive load of 100 kilonewton. Therefore, the objective of the experiment was successfully achieved, demonstrating that coconut fiber can be used as an environmentally friendly alternative material for hollow concrete brick. This result indicate a 6.97% reduction in weight after 7 days of curing due to moisture loss. No theoretical or control value was provided for comparison. For future work, it is recommended to investigate different coconut fiber replacement percentage and extend the curing period to 28 days to obtain the standard compressive strength conducted to provide a more comprehensive evaluation of coconut fiber hollow concrete brick. This improvement will provide a clearer understanding of the material's long-term performance and suit- suitability for practical construction application. So that's all for us for this presentation. Thank you.